All right, so these notes are going to be on 6.1, trigonometric functions and acute angles. I'm going to give you two different right triangles. Well, they're the same, but the angles are going to be in different locations. This is called theta. I'm going to put theta up here, and then I'm going to put theta down here. Now, opposite of the 90-degree angle is always going to be the hypotenuse. The side touching theta is going to be the adjacent. The side opposite the theta is going to be the opposite. So if theta is up here, know that this is the adjacent, this is the opposite. However, on this triangle, the theta is down here. So the side touching it, the adjacent is now at the bottom, and the side opposite is over here. The only thing that's the same is the hypotenuse. The hypotenuse is going to be the same. Now, these are going to be 6 basic trigonometric functions of the angle theta. Now, sine theta is going to be the opposite over the hypotenuse. This is so, remember? So, sine opposite over hypotenuse. The cosine of theta is going to be the adjacent over the hypotenuse. And then the TOA, the tangent, is going to be the opposite over the adjacent. Now, these are 3. Now, where are the other 3? The opposite, the reciprocal of sine is called the cosecant. And it's basically just a reciprocal. So the hypotenuse is going to be the numerator. The opposite is the hypotenuse. Is the denominator, sorry. The reciprocal of cosine is going to be secant. And that's going to be hypotenuse over adjacent. And then the opposite, or the reciprocal of tangent, is cotangent. And that is going to be the adjacent over the opposite. Now, the way I always remembered it is by the opposite letters. So the sine is going to go with the cosecant because the letters don't match each other. And then the cosine is going to go with the secant because the letters don't match each other. The cosine and the cosecant, since the C's match, those don't go together. That's how I always remembered it. And then cotangent, obviously tangent. We'll start off with an example. Given the right triangles below, I want you to write the 6 trigonometric ratios for the given angle with measure theta. I'm going to go ahead and put theta up here. This is going to be a 20, a 21, and a 29. Now here, according to the hypotenuse is always going to be opposite the 90. So this one is the hypotenuse. The adjacent is always touching the angle. So this is going to be the adjacent here. And the opposite is opposite of the angle. Now it's asking for the sixth trig. So it's asking for the sine, the cosine, and the tangent. The sine, the reciprocal is going to be the cosecant. The reciprocal of cosine is going to be secant, because remember the letters, the first letters don't match. And then tangent is going to be cotangent. Sine. Sine stands for opposite over hypotenuse. The opposite number is 21 over the hypotenuse is 29. Cosec is just a reciprocal, so I'm just going to, that's 29 over 21. The cosine is adjacent over hypotenuse. Adjacent over hypotenuse. Here's the reciprocal. And the tangent is the opposite over the adjacent. Let's go on to example 2. What are the trigonometric ratios of theta in a right triangle with the given value? Now here I'm going to tell you the tangent of theta equals 15 over 8. So I'm going to need to draw a triangle with those sides. So first start off with drawing your triangle. Label one side theta. I'll go and I'll put the theta down here. Now tangent. Tangent is opposite over adjacent. According to this angle, this is going to be the hypotenuse. This one is the adjacent. And then this is going to be the opposite. So I'm going to put the numbers where they belong. The opposite is going to be a 15. So this is going to be side 15. The adjacent is going to be 8. What they didn't give me was a hypotenuse. So I need to find out what the hypotenuse is. And the way that I'm going to find the hypotenuse is by doing the Pythagorean theorem. So I'm going to do the Pythagorean theorem. I have a squared plus b squared equals c squared. I don't know what the hypotenuse is. I have an 8 squared plus a 15 squared equals a hypotenuse square. 8 squared is going to be 64. 15 squared is 225. I'm left with 289. And then I'm going to take the square root, and I don't need plus or minus because you can only have a positive side, and that's going to be a 17. So the hypotenuse is going to be a 17. Now you have to find out what the sine is, the cosine, and the tangent, which they already gave me the tangent. The tangent is 15 over 8. So the cotangent is 8 over 15. Now the reciprocal of sine, remember letters don't match, so C, that's an S, so I want the C, so that's cosecant, and this would be secant. Now the sine, that is opposite over hypotenuse. I'm just taking the reciprocal. Cosine is adjacent over hypotenuse. Go ahead and hit pause and try this one, and then hit play and see if you get it right. I'm going to go ahead and solve it now. This is cosecant. On cosecant, this is the hypotenuse. And this one right here is going to be the opposite. So I'm going to draw my triangle. I'll put theta down here. Now this is going to be my hypotenuse. This is my adjacent because it's touching the angle, and this is my opposite. The hypotenuse number is going to be a 25. The opposite number is going to be a 24. I'm going to have to do my Pythagorean theorem to find out what the adjacent is. So I'm going to do the adjacent square plus 24 square equals 25 square. Adjacent square plus, that's going to be 576. This is going to be 625. I'm going to subtract 576 to both sides. So the adjacent square equals a 49. And the square root of 49 is going to be 7. Now, this was also a Pythagorean triple. They gave me the cosecant. Reciprocal is the sine. Cosine is adjacent over hypotenuse. I'm going to take the reciprocal. Tangent is opposite over adjacent. I hope you guys got that one right. On the next example, I'm going to create a word problem, and this is going to go into solving it. A fire truck has an 84-foot ladder extended against a building, forms a 55-degree angle with the top of the truck. The truck is 8 feet tall. The firefighters are trying to reach a window that is 75 feet above the ground. Is the ladder long enough to reach the window? I'm going to go ahead and I'm going to sketch this out here. Here we have the building. Now, here's your fire truck. Keep in mind that the fire truck was 8 feet tall. And then the building was 75 feet tall. Well, the ladder is going to go to the top of the building. And the ladder is 84 feet. This is going to be my ladder. So remember, you have to keep in mind that you're 8 feet above, correct? Now, this is going to be your right triangle right here. lighting's a little better now. And then it says that right here it said the building forms a 55-degree angle with the top. So this right here is going to be 55 degrees. I'm going to pull this triangle out. Now the ladder is going to be 84 feet. This is going to be 55 right here. Now this piece right here, remember that this was 75. And if the truck is 8, 75 minus 8 is 67. So this is going to be a 67. Now I need to know if the ladder is long enough. So that's going to be my variable. I just need something smaller than 84. So what I'm actually solving is this is 67 feet. This is 55. And I'm going to say this is X. This is what I'm solving. And I just need to make sure that X is less than 84 because I only have 84 feet of ladder to use. Now, I don't know what I'm going to use. Okay, so according to this angle, this is going to be the opposite. This is the hypotenuse. I don't know anything about the adjacent side. What I do know is SOHCAHTOA. Since I don't know anything about the adjacent side, I'm going to cross off anything with the adjacent. So I'm going to be using the sine. Sine is going to help me solve. So I'm going to say the sine of the angle, which is 55 degrees, is equal to the opposite, which is 67, divided by the hypotenuse, which is X. I'm solving for X. So I'm going to go ahead and I'm going to multiply both sides by X. So now I have an X sine of 55 is equal to 67. I'm going to divide by a sine 55 degrees. In your calculator, make sure you are in degree mode. Make sure you are in degree mode. So mode, I'm in degree mode. I'm at 67 divided by the sine of 55, and I get 81.792. Now, because that is less than 84, then yes, the ladder is going to reach. Yes, the ladder will be long enough. Because it is less than 84. Let's do another word problem. The sun shines at a 60-degree angle to the ground. How long is the shadow cast by a 20-foot tall flagpole? So here's our sun. And then we have a flagpole. And it says the sun shines at a 60-degree angle to the ground. So 60-degree angle to the ground. So right here, this is going to be a 60-degree angle. And a flagpole is 90 degrees to the ground. How long is the shadow cast? This is going to be the shadow right here. This is the shadow. So that's going to be my variable with a 20-foot long pole. So this is going to be 20 feet. So here's our right triangle. According to this angle, this is the adjacent. This is the opposite. I know nothing about the hypotenuse. So we have SOHCAHTOA. When I'm trying to figure out which one to use, since I don't know the hypotenuse, I'm going to take out anything with the hypotenuse. So I had to solve with using tangent. So it's going to be the tangent of 60 degrees is equal to the opposite, which is a 20, over the adjacent, which is the variable, the shadow. Go ahead and multiply both sides by x. So x times the tangent of 60 equals 20. I'm going to divide both sides by tangent 60. So I have 20 divided by tangent 60, and I get 11.547 feet. So how long is the shadow cast? The shadow is about, I'm going to just say 11.5 feet. Let's go ahead and do another word problem. Or not so much a word problem. We're going to have triangle MNO is a 45, 45, 90 triangle. With side length OM equals 2. What are the 6 trigonometric ratios for angle N with measure theta? So here I'm going to have OMN. I'm going to list what I know. I know that OM equals 2, so OM equals 2. This is a 45, 45, 90. And they're saying that the theta is going to be the N. So this is going to be your theta. According to this angle, this is the adjacent, this is the opposite, and this is the hypotenuse. Now, they did not give me these two measurements. However, this is a 45, 45, 90. That means these legs have to be the same. So if this is a 2, then this is a 2. Now, you can go ahead and you can do your 45, 45, 90 ratio, or I could do the Pythagorean theorem here. 2 squared plus 2 squared equals hypotenuse squared. 2 squared is 4. 2 squared is 4. So 4 plus 4 is 8. If I take the square root of both sides, the square root of 8, that breaks down into a 2 and a 4. And the square root of 4 is going to be a 2 square root of 2. The sign here. Sine, cosecant, secant, cotangent. And don't forget the argument. According to this angle, sine is opposite over hypotenuse, which these cancel out, and I'm left with 1 over radical 2. Now, if this is 1 over radical 2, this is going to be a radical 2 over 1. On this one, however, I can't have a radical 2 in the denominator, so I'm going to multiply the top by radical 2 and the bottom by radical 2. So the top is going to be a radical 2 over square root 2 times square root of 2 is just equal to a square root of 4, which is a 2. Cosine is adjacent over hypotenuse. This is going to be 1 over square root of 2. So this one's going to be a square root of 2. And I just rationalize this one. So I'm going to keep it the same. That's going to be the same answer. Tangent. Tangent is opposite over adjacent. Last example. Triangle JKL is a 30, 60, 90 triangle with side length LK equaling 4, and the measure of angle J equals 30 degrees. What are the 6 trigonometric ratios for angle J with measure theta? So I'm going to say that this one is the J, this is L, and this is K. J is going to be 30 degrees. LK is going to be the number 4. Now, we are doing everything according to angle J. So according to this angle, this is the adjacent, this is the opposite, and this is the hypotenuse. If I do my 30, 60, 90 triangle right here, remember that the opposite, the 30, is the 1. The hypotenuse is the 2. So the hypotenuse is double that. So that'll be an 8. And if this is the 1, then this is going to be a 1 radical 3, which is going to be a 4 radical 3. The sine is equal to the opposite over the hypotenuse, which is going to be a 1/2. This is the reciprocal, so that's just 2 over 1. The cosine is the adjacent over the hypotenuse. Now the 4 and the 8, those reduce, and you're left with a 2 in the denominator. Now the secant is going to be the reciprocal of that. You cannot have a radical 3 in the denominator, so I'm going to multiply the top and the bottom by radical 3 to rationalize it. In the numerator, I'm left with 2 radical 3. In the denominator, that's just going to be a 3. And tangent is opposite over adjacent. The 4's canceled. I'm left with 1 over radical 3. The cotangent is just going to be a radical 3 because it's a reciprocal. I can't have a radical 3, so I'm going to multiply top and bottom by radical 3. And the final answer here is going to be a radical 3 over 3. And that concludes our notes.